Hello, welcome back to another IB Math Speedrun with me, Vince. So in this speedrun, we're going to be finishing up Chapter 6 by looking at Chapter 6.5. So let's jump right in. So the first part of Chapter 6.5 is all about, the chapter is all about trigonometric equations. And so first, we need to know how to solve them. And it's pretty similar. Normally, if we want to find the roots of an equation, the thing is there are an infinite amount of roots since the equation crosses the line 0 an infinite amount of times. So normally we only give the roots within a certain predefined area. If that area isn't defined, I'd usually just use between 0 and 2 pi or 0 and 360 degrees, just like that. Give the values between, say this is 0 and this is 360. Give the values between there. So yeah, let's jump right into some questions. So the first question is, just find the roots of the following equations, both algebraically and graphically. Okay, so the first equation is cosec squared cosecant squared theta is equal to 3 cotangent theta. I guess I'll just use 0 for the theta symbol. Minus 1. So let's solve this first. Well, let's try and solve this algebraically. And what we want to do is we want to express all of the equations in terms of one trigonometric function. In this case, we have 1 over sine theta, 1 over sine squared theta is equal to 3 times cosine theta over sine theta minus 1. So if we multiply everything by sine theta, what we get is sine squared theta. 1 is equal to 3 sine theta cosine theta minus sine squared theta. And what we can do is sine theta, cosine theta. Can we express this in terms of sine theta? Yes, but it would be ugly. So is there a better solution here? Oh, I guess we can... Technically, we can make this 1 equal to sine squared theta plus cosine squared theta. And then so what we have is we can factorize this. So we have 2 sine squared theta minus 3 sine theta cosine theta plus cosine squared theta is equal to 0. So can we factorize this? Yes, barely. So this would be 2 sine theta minus cosine theta times sine theta minus cosine theta is equal to 0. So therefore, 2 sine theta is equal to cosine theta. 2 sine theta is equal to cosine theta. So 2 tan theta is equal to 1. So tan theta is equal to 1/2. So we can solve for that. Actually, let's just solve for that. Where's my calculator? Oh, so we have inverse tan of 1/2, which is equal to around 0.464 radians. But the other case is that sine theta is equal to cosine theta. So in this case, tan theta is equal to 1. So this would be pi over 4 radians, which would be equal to 0.785 radians. And of course, these values will repeat infinitely, so I'm just going to give one value for each one. 0.463. Okay, yeah. So these should repeat infinitely in theory. So next and final equation, we have 2 secant squared theta minus 3 plus tan theta is equal to 0. So what can we do over here? I guess we can multiply everything by cosine squared. So this makes it 2 minus 3 cosine squared theta plus sine theta cosine theta is equal to 0. And like the previous one, we can expand this into 2 sine squared theta plus sine theta cosine theta. And then we have minus only cosine squared theta in this case. It's equal to 0. So what we have here is 2 sine theta minus cosine theta times sine theta plus cosine theta is equal to 0. So again, like the last time, we have one root will be equal to tan theta equals 1/2, or theta is equal to 0.484. Is it 484? 384. Arctan 0.5, 464. And the other value will be for when tan theta is equal to -1. And tan theta equals -1 when we have 3 pi over 4. So we have 3 pi divided by 4. We have 2.36 as our other value. So yeah, those should be correct. And that is all for this speed run. I hope to see you in the next one. So see you then.